Well, thank you very much, Rodney. That was a great overview. And it's great to be here today. I'm going to tell you, my job is normally managing a team of account technology strategists. And these are folks who go out and actually go and hit the whiteboard with our partners, architecting solutions, designing the solutions, making sure that the hardware and the software solutions that our partners are building work in and out with Windows, making sure that we're building something that is better together and better than the sum of its parts. So it is not every day that I sit in front of an audience this large. I'm used to being in cubicles and in small rooms, but it's great to see such a large audience here, and terrific to be able to have an opportunity to talk to you today about our Windows 10 IoT editions. And I'm going to give you a high-level overview of those editions, and wanted to point out this afternoon we're going to have some great breakout sessions in which we talk more about those IoT solutions. We're going to have some breakout sessions in the afternoon where we talk about lockdown features, imaging, drivers, debugging, management of devices, and the like. So I'm not going to really do a deep dive here this morning, but I'm just going to kind of keep everything at a very high level. And again, thank you for the opportunity to speak with you today. So I'm going to kind of reiterate what Rodney said, just so you have a common framework or a set of pillars that we can kind of use to frame the discussion about Windows 10 editions today. And the first is that we are talking about a common core, down to the kernel that's used for our products. And that common core is what we have built all of our Windows 10 IoT editions on, whether it be the Windows 10 IoT Core Edition, the Windows 10 IoT Mobile Enterprise Edition, or the Windows 10 Enterprise Edition. They're all built on a common core. Thus, they're Windows through and through. And with that common core comes things like a consistent deployment experience. You can use the same tools to create images and to deploy your images. You get the ability to have a consistent management experience using things like the OMA, DM APIs and protocol stack, along with tools like Windows Intune, Windows System Center Configuration Manager, and third-party MDM utilities. These are things that are already used in your business, in your IT departments for managing clients, managing handheld devices. And we can extend those technologies to be able to manage the realm of different devices that comes in the world of IoT. And finally, it's a connected world. Not only connected locally with sensors and peripherals that attach to these Windows 10 IoT editions, but also these devices that connect to one another and need to do so securely. And then you need to be able to connect to the cloud, whether it's our own Azure cloud or whether it's third-party clouds, and you need to be able to do that again securely and in a way that is interoperable, in a way that works across Windows and other platforms. And that's something that we'll continue talking about as well. The three editions of Windows 10 IoT we're going to talk about here are Windows 10 IoT Enterprise Edition, our Windows 10 IoT Mobile Enterprise Edition, and the Windows 10 IoT Core, and the Core Edition. I'm going to talk about a little difference between Core and Core Pro here as we come as well. But what we're looking at is Windows 10 IoT Enterprise. That is our full version of Windows 10. It's the Windows 10 you know and love on your desktop. And it, as Rodney mentioned, it has some features that allow it to be used for more embedded applications where we can lock it down. And we'll talk about those lockdown capabilities. It's also the only edition that supports Windows 32 applications and legacy .NET applications as well. So what we have there is a platform that can run not only legacy Windows workloads, but also modern workloads that are built on the Universal Windows platform. It's used in a realm of different devices, and it's the only edition that's really capable of taking advantage of the power of the most modern chipsets, the most modern processors, a lot of memory, a lot of storage, and the like. It is definitely the choice of operating system that we use for power workloads. The IoT Mobile Enterprise Edition is our edition that works on the realm of handheld devices. So whether they're handheld terminals or mobile POS solutions or mobile tablets, the idea behind that is that we're supporting ARM hardware. That in Windows 10, these are platforms that also have a shell and that can run Universal Windows Platform applications or our modern apps. So any apps that you write for enterprise are also compatible with mobile enterprise as well when they're built using the UWP model. There's also advanced lockdown capabilities in mobile. And with Windows 10 for mobile enterprise, we've added the ability to support multiple users. So we can identify who a user is, put them into a group, and give them a different device experience depending upon what they are and what their role is, which is terrific. And then there's the Windows 10 IoT Core Edition. And this is, like Rodney mentioned, it's core through, it's Windows through and through, but it has a much smaller footprint. It's available in editions that work on both x86 and ARM. Has a minimum memory footprint in a headless mode of only 256 megabytes, which for Windows is small, very small. And in a headed scenario, 512 megabytes. A very small storage footprint, relatively speaking, for Windows as well, at only 2 gigabytes. The key differentiating factor here with Core Edition is that there is no shell. So when you boot to Core, you aren't granted with that familiar with Windows desktop experience. What you do instead is you write a universal Windows application that provides the functionality of that shell, basically. It is what provides the device experience. And the Core Edition boots straight into that application. Tremendous number of workloads that can potentially be run on Core. And basically, since it is Windows through and through, it's great for things like zero terms, very thin and lightweight terminals. It's great for your lower-end digital signage offerings. It can be used to create gateway devices, headless gateway devices, or headed gateways that are used in industrial or industrial or home applications. And it's available at basically a great cost as well. The Core Edition is available to the maker community for free. And is used widely on devices like the Raspberry Pi and the Minoboard Max, the Dragon board and the like, as well as a number of other maker boards and industry boards that are being announced all the time. The Core Pro Edition is a version that's available to our OEM partners. And the big differentiating factor behind Core is the OEM support model that comes with it, as well as the OEM servicing model that comes with it. With Core, and we'll talk more about this afternoon, with Core Pro, you get the ability to defer updates. So you have an opportunity as an OEM to be able to test the platform with updates and then be able to optimize your platform for those and deploy those updates at a later time. All of this is about one Windows, and an enabling technology behind this is the creation of the Universal Windows Platform. This isn't something that's brand new. It actually has spun out of the effort that we started with the Windows runtime back in Windows 8. And when Windows 8.1 became available, we aligned the Windows runtime with Windows Phone 8.1 and Windows. And now with Windows 10, we had an opportunity to optimize it even further, where we are now aligning with not only desktop and client PCs and tablets, but with mobile devices and with this range of core-powered devices that exist as well. The important thing here is that we have a consistent set of APIs and a consistent set of device driver interfaces. And using those, we're able to create applications that work across this whole range of products, as well as creating device drivers. So if you're creating hardware, if you're creating peripherals, if you're creating sensors, you create the hardware, you create the driver, and it can work across the entire set of offerings. No longer do you just write it and have it be dependent upon a single edition. And the best part is that if you're familiar with Windows development, you already have the tools in your toolbox to be able to accomplish all of this. Now, when it comes to the Universal Windows Platform, again, I'm not going to spend too much time on this, but again, we give you the converged API set you need to be able to write an app once and to have it work across the gamut. You're going to see there that there's languages that are going to be familiar to you, whether it's C++, C#, but also the newer languages or the IoT kind of languages like Python, Node.js, and the like. You're going to see support for traditional Windows APIs in part of this converged API set, but also things like the wiring API, which can make it a lot easier to develop apps and device drivers. And all in all, you're also going to be deploying these applications in ways that are familiar to you with Windows, whether it be using AppX or Xcopy or the other deployment mechanisms that are available today in Windows. And again, your investment in Visual Studio and in PowerShell and the like, this is something that can be leveraged across the entire set of development efforts. Likewise, with Windows drivers, and this is really cool, is if you write a driver that is also compatible with this converged API set, it works across all editions, which is something that is just unheard of. It didn't exist before. And we did a lot of work to kind of scan the drivers that were in place. We are known for supporting drivers on our products, and we scanned over 100,000 drivers to come up with this universal driver API set between the products. And as you can see, they support a very large number of devices. So we give you the APIs to be able to write drivers and plug them in across all the editions. The other thing that exists, and this was a Windows 32 feature, was the ability to be able to do things like GPIO, I2C, and SPI, being able to talk directly with these buses to hardware. And that's very important for IoT scenarios. And we realized that we're going to have that functionality in our universal Windows platform so that we have the same functionality across not only enterprise client desktop, but across mobile enterprise and across Windows 10 IoT Core as well. As I mentioned before, the wiring API there as well, which makes it even easier to develop UWP for your devices. Security. What I'm going to talk about now is relevant most to our IoT enterprise and mobile editions. And we're going to talk about three types of functionality that are present in these two editions, but by no means are these the only ones. And please pay attention later in some of the deep dives, and you'll be able to learn even more about technology, about the enabling technologies that are increasing security across our platform. But realize we are an enterprise-oriented company, and when it comes to our software, when it comes to the code that we developed, security is first. And in the world of Internet of Things, we need to take security extremely seriously as well. If you're going to be connecting all those devices and exchanging all this data, we need to be able to do so in a secure way. And also the platforms that are generating this data need to be able to lock down in various ways. So the first technology is Passport. And what Passport is it's a kind of something that builds on next generation credentials. You may be familiar with something called Windows Hello, which gives you the ability to use infrared cameras to do facial recognition or fingerprint readers to be able to do different kinds of biometric. And Passport takes both the device identity along with modern credentials provided by Hello to be able to give you an experience that allows you to do away with the traditional password. By simply using a gesture, showing your face, swiping your finger, or typing in a PIN number, you can authenticate not only to the device, but also authenticate to the services that that device is being connected to, and do so in a secure and very difficult to defeat way. Bitlocker is not something new. It's been around for quite some time, in many editions now, but it's our full volume encryption product, and it allows us to encrypt data, both the operating system data and the device data, and make it so that if a device is stolen or if it's otherwise compromised in some fashion, that if you don't have the key, you're not able to even read the data that's on the disk. How we're expanding that is we're making Bitlocker basically cloud capable now by allowing it to work with our Azure Active Directory services. And so the keys that are used by Bitlocker for decryption and data can now be stored and recovered in Azure Active Directory, enabling you to have devices that connect via Azure AD. And Device Guard is kind of an umbrella for a number of different technologies that are dependent upon both hardware functionality and software functionality. So we're talking about modern UEFI firmware, about modern TPMs, and also Windows software, things like trusted boot and secure boot, being able to measure and attest to the boot. And we're putting all of these things together to create an experience that makes it so that only trusted code can be run on an operating system. So what we have here is on Windows, we have it so that it will only run code that has been signed and approved by your organization. It will run no other code at all. So that's a very different model. You may be more familiar with the kind of trust first, ask questions later model where you run the code. Maybe you have antivirus and anti-malware, which go ahead and scan the code and see if there's anything wrong that needs to report. Well, in this case, it's the other way around. Even if a system was compromised, an attacker wouldn't be able to run malicious code because it's not on the approved list of code to be executed. So, technologies like these are really enabling us to deliver enterprise-grade security. And this is, Well, I'm talking about enterprise and mobile in this case. The same philosophy goes and works across all of our products. I want to now talk about some features that are relevant for IoT enterprise. And what we're talking about here is the ability to do advanced lockdown. Now, we can lock down all of the editions in various ways, but the features I'm talking about here are specific to our Enterprise Edition, Windows 10 IoT Enterprise. The first is our unified write filter. So obviously, you need to be able to protect the OS, protect your apps, protect the data that's on that. And so if you can't change the data that's sitting on the disk, then you've accomplished that goal. So with the unified write filter, we're able to lock things down. This is extremely useful for things like kiosks and things that sit out in the public. You want them to work and have a predictable use and experience every single time they're used. Any changes you made, you basically want discarded, and you want to start with the fresh experience each and every boot, each and every user. The second is the ability to automatically launch a line of business app or a shell environment that delivers the experience of that device. We do this in two ways. We can do it for modern apps, our Universal Windows Platform apps, using a technology called assigned access. We can do it with legacy Win32 apps using something called the shell launcher. And at that point, you're able to designate an app that basically starts and provides the experience of that device. And then we're able to do things like ignore keystrokes and key combinations that would allow someone to potentially try to get around that. So the interaction with the device is basically through the app, through that line of business app. Very useful to lock things down. And if you want very granular control over the UX, we give you that as well. We have App Locker technology, which allows you to specify for each user a list of applications that can be run. And as always, you have the ability to customize your start menu, your taskbar, to be able to do things like automatic login, etc. One Microsoft, one Windows. So there has to be one management story as well for all of this, otherwise it wouldn't follow the one message that we're trying to communicate here today. And so, again, we've got a range of devices across these small devices, our gateway type devices running core, our mobile devices running mobile enterprise, our industry devices that are running Windows 10 Enterprise. We've built into Windows 10 a common mobile device management stack, a common servicing stack, and a common set of configuration service providers that can be used via different tools and via the OMA-DM protocol to be able to deploy, configure, manage, and monitor these devices. And again, it wouldn't be part of this one story if we couldn't really do it across the board. So whether you're using our Intune service, whether you're familiar with System Center and the System Center Configuration Manager product, or the variants of it that are now available in the cloud on Windows Azure, or whether you're using third-party MDM tools, you now have the ability to manage your Windows 10 IoT devices and your Windows 10 IoT editions, just like you would any other version of Windows, and just like you would, your client devices or your handheld devices that you might be managing with these tools today. Now we're to that third pillar, to connectivity. And when we have all these Internet of Things, they're not going to be much of a things, if we can't connect them together and communicate somehow. Microsoft was a founding member of the All-Seeing Alliance and is a premier member, of that organization. And we've built all-join support into all of our Windows 10 products. What does this do? It gives us the ability to discover devices. When a device comes onto the network, we can recognize it, we can query it, we can figure out what is it capable of. Is it something that can, display notifications? Are there certain actions I can take based on what that device is capable of doing? Then it gives me a way that I can securely, communicate those messages between the devices and the like. So this is built into Windows 10 across all those editions. The developers have APIs that allow them to access this as well. Like Roddy mentioned, OCF is just a recent announcement of a couple of weeks ago. But as part of the OCF effort, we'll be seeing OCF support also added into Windows 10 and the like going forward as well. So to summarize, what it's about is all about supporting interoperability, not only across Windows-powered devices, but across the whole ecosystem of devices. Because if we can't discover, find, and get the data off of those things, we're not going to be able to build the Internet of our things. Kind of the second prong of that connectivity fork is obviously the ability to connect to the cloud, not just to connect on the local network, but to be able to connect to the wide area of the cloud network. There's going to be some sessions this afternoon. My colleague Changsop is going to be up here shortly to talk about Azure. And there's a session this afternoon as well on the Azure IoT suite, specifically around the two offerings within the suite today, remote monitoring and predictive maintenance. So I'm not going to spend a lot of time here, but what I want to basically emphasize is that using Windows 10 IoT, all the additions on any of the devices, you're going to be able to get them certified, number one, with a Certified for IoT program, and you're going to be able to get them connected, whether they connect through a field gateway device. They might be on a network where they don't have direct internet connectivity. They might even be on legacy devices or non-Windows devices or speaking protocols that aren't TCP/IP or capable of being transported over Ethernet, right? So we have gateways that enable us to see and communicate with those devices. In turn, we're able to connect those devices via gateways into the cloud. And once they're connected to Azure, that's kind of where the magic really happens. Azure has a number of different services via which you can build very robust and powerful products. We have the ability to connect to literally millions of devices, process millions of messages, to be able to store that data not just for the day, the hour, but the week, the month, the year, the decade, and then to be able to use very powerful analytical tools to be able to analyze that data, to be able to put it through very powerful machine learning algorithms, and to be able to learn from this data, to be able to make business decisions based on this data, and to be able to visualize it in ways that are sensible, using tools like Microsoft's Power BI. We need a way of being able to wrap our heads around all the data that the IoT devices are capable of generating. So we're going to have some great messages on that this afternoon. And so we've reached the end. I'm a little bit early, but it's a great time to kind of summarize and look back on what we've talked about so far. So if there's a few things I want you to keep in mind, it's the following. Number one Windows, the common core, the common universal Windows platform, and the common universal driver model. They provide a single way that a single development investment in Windows can be leveraged across a whole range of devices. What you do for the client and the tablet works for the handheld, and that works for the IoT device. You don't need to learn how to do anything new. We're trying to implement support for management protocols, for deployment tools, image creation tools, and the like that you already know and that you use in your enterprises today, and that these same tools can be leveraged and utilized for building IoT solutions. Enterprise-grade security. Absolutely goes without saying. We aim to be the most secure platform that there is out there. And we work very hard at Microsoft to ensure that we are, and to add functionality and features to the product that help it be among the leaders out there. The other thing I want to talk about too, are just that idea of standardization. Microsoft isn't about kind of doing it our own way all the time. There's times where we want to be leaders and come up with the ability to standardize things across an industry ourselves, and work with partners to do that. So the OCF effort is just like that. What the W3C was for the internet, OCF we hope is going to be for the world of internet connected devices, and that we will have standards and protocols that allow us to interoperate between any kind of IoT device out there. And then finally, that connectivity story revolves around being able to connect to the cloud. We would love you to connect to our Azure cloud, and are going to tell you everything there is to know about it today, I hope. But also to other clouds as well. The idea there is being able to, again, have this one platform, one set of tools, the power of Windows, to be able to power your Internet of Things. Thank you very much. I appreciate the time.